Hiten, Japan's quiet pioneer of deep space exploration. In the early 1990s, while much of the world's attention was fixed on the space shuttle and ambitious plans for Mars, a small, understated spacecraft quietly rewrote the rules of space travel. Its name was Hiten, and although it lacked dramatic imagery or headline-grabbing budgets, it became one of the most influential missions in the history of orbital mechanics. Launched in January 1990 by Japan's Institute of Space and Astronautical Science, ISOS, Hiten, meaning Flying Angel in Japanese, was Japan's first lunar probe. On paper, its mission seemed modest: test deep space technologies and support the deployment of a tiny subsatellite called Hagoromo, which was intended to orbit the Moon. Yet when Hagoromo failed shortly after deployment, Hiten's mission took an unexpected and far more ambitious turn. Rather than abandoning the spacecraft, mission engineers chose experimentation over caution. What followed was a bold exploration of low-energy orbital paths, an idea that had existed mostly in theoretical mathematics. Instead of taking a direct, fuel-intensive route to the Moon, Hiten was guided along a complex trajectory shaped by the subtle gravitational pulls of the Earth, Moon, and Sunday. This method, later known as the ballistic capture or weak stability boundary approach, allowed the spacecraft to reach lunar orbit using far less fuel than traditional methods. At the time, this was revolutionary. Conventional space missions relied on powerful engines and precise burns to force a spacecraft into orbit. Hiten demonstrated that patience and physics could sometimes replace brute force. By exploiting gravitational dynamics, the probe entered lunar orbit in 1991 with minimal fuel consumption, an achievement that astonished mission planners worldwide. Hiten's success had consequences far beyond Japan. Its trajectory provided real-world proof that low-energy transfers were not just mathematical curiosities, but practical tools. This insight influenced later missions, including NASA's Genesis spacecraft and various asteroid exploration projects. In an era where cost efficiency and long-duration missions are increasingly important, Hiten's legacy continues to shape mission design. Beyond engineering, Hiten also symbolized a shift in how space exploration could be approached. Rather than competing directly with superpowers through scale and spectacle, Japan demonstrated the power of precision, creativity, and scientific risk-taking. The mission showed that innovation does not always require massive rockets or dramatic landings. Sometimes it emerges from rethinking assumptions that others take for granted. Hiten's journey ended in 1993, when it was deliberately sent into the Moon's surface. There was no live broadcast, no triumphant countdown. Yet its impact endures quietly, much like the mission itself. Today, as space agencies and private companies search for sustainable ways to explore the solar system, Hiten stands as a reminder that progress in space is not always loud or immediate. Sometimes, the most important revolutions happen almost unnoticed, guided by gravity, mathematics, and a willingness to try something different.